This is the briefing for Mech 434 Challenge 1 Factorial Design. We have 8 helicopters with 4 design factors. Wing length, minimum maximum, body width minimum maximum, body length minimum maximum, paperclip installed or not. And so we are going to test every factor, low or high, and each of the design parameters at the same time by testing every combination of helicopter at once. That's why it's called a 2 to the 4 factorial design, 2 to the 4th power, or 16 helicopters to test. There is a major error that you'll notice here. That plane 8 and plane 1 are the same. My classmate laser cut these for me and I didn't check, so that's on me. That is a major limitation in my experiment, and if you want to know more, you can check it out in the report. So what I did was I dropped the helicopters I dropped them one by one from the same height and the same position and recorded how many seconds it took for them to hit the ground with the goal of increasing the flight time. And I forgot to test, I think that was 1B. I should have labeled them better on the graph, but so after we collected all the data, we made a nice chart of it there, and that's what we used as the basis for our analysis. So I did the first calculation of the individual factor of body width myself just to prove I could do it, and then I fed the rest of the data into Claude AI as a screenshot, and it came up with this. We can see here that body width removes a full 0.94 seconds from flight time, and I'm thinking maybe that's because it's hard to see. That's better. The paper is so thin, it's about 90 to 100 GSM, and it just gets buffeted around even by the atmospheric conditions in the Mechatronics building. So wing length is a positive factor when it's long at plus 0.76 seconds. And we were seeing all this behavior in the chart, but there were these unexpected, body length, but the clusterings, these two suddenly jumped. What's up with that? And most of them are around 6, but the ones with narrow body are a lot higher, and maybe there's some other stuff going on. And to find that out, we turn to our 2-factor analysis. So Claude AI was really great for visualizing all this data. It did it exponentially faster than I could. And here we see a lot of strong interactions, which might explain these sort of strange clusters and jumps in the data, which you could see also in the erratic and sort of unpredictable flight of the helicopters. I thought it was pretty cool how I could use AI to determine the effect of one design choice on a paper helicopter. This might help grow Factorial Design in its niche. when we're flying the helicopters, it's pretty easy to see the effect of putting a paperclip on a long-winged helicopter or short wings on a long body. But this way, we can actually quantify these interactions. We can quantify every single one of the interactions with AI, and with AI, we can do larger and larger factorial analysis.